consumption. It refers to the electrical energy supplied to operate something. It's measured in units of watts, and it's the rate of using or producing electrical energy. With power consumption, we also need to consider electricity consumption, which is measured in kilowatt per hour and represents the total amount of electricity that has been consumed over a certain time period. Standby power is also known as leaking electricity, and it can account for 10% of all electricity used. Different from clocks, devices such as laptops and phones consume electricity without offering any visible features when in standby mode. These and many others are known as energy vampires. Peak power is the maximum power that a power supply can sustain for a short period of time. Most devices have a label that shows how many watts they use, indicating the amount of power they consume. In the chart, we can see that electronics consume or require less power to operate than regular household appliances. However, since the energy consumption will be the integral of the power consumption over time needed to perform the operation, what really matters is the energy that any electric device uses. So which one do you think uses more electricity? The smartphone in your pocket or the fridge in your kitchen? Well, smartphones are very energy efficient because they are designed to run on a battery for a long period of time. Cell phones use approximately 2 to 6 watts when charging and 3.3 kilowatt per hour per year. That is less than the 400 kilowatt per hour per year it requires to charge the average family refrigerator. However, while smartphones don't have exhaust pipes pumping out carbon dioxide and use less energy, they are useless without mobile phone towers, Wi-Fi networks, and data centers that are always on. So, if somebody watches just 1 hour of a video each week for an entire year, this requires more total energy than running 2 standard fridges for the same amount of time. It is estimated that 50% more energy is used to move your data than to move a plane. The wireless protocol. For bulk high-speed transfer, Wi-Fi is the preferred protocol, but unfortunately, the constant listening of the receiving device will consume considerable amounts of power. Energy vampires. Electronics that use standby power add heat to a household, create additional load for air conditioning, and even when only consume small amounts of electricity, a household or a building full of them add up to a noticeable amount of monthly electrical consumption. Why? Because they are always on. For example, to turn a TV on with a remote, the remote has to be on to receive the signal. If it's a smart TV, it has to be on to stay online. Same applies to devices that depend upon external supplies, such as a USB. Power consumed in standby mode is also the same as the energy consumed when loading a battery. Electricity production. The variety of fuels used to generate electricity all have the same impact on the environment. Fossil fuels power plants release air pollution. They require large amounts of cooling water and can spoil large amounts of land during the mining process. To generate electricity, most power plants burn coal, crude oil, or other fossil fuels. As power plants burn more fuel to create more electricity, the extra carbon waste traps a lot of heat. Coal-fired power plants contribute to about 41% of global electricity, and it is vital to energy sources. So what should we do about it? Reduce energy vampires. Keep appliances and electronics unplugged when not in use. Use power strips that have built-in timers that allow to cut the power according to a certain schedule. Digital gadgets. Digital gadgets have become cheaper and more sophisticated power-saving devices. They can help with lowering the power consumption and make it possible to estimate energy consumption. Decreasing power plant emissions. Cutting back on energy consumption reduces the amount of electricity that power plants have to make, subsequently reducing the amount of fossil fuels that are burned each day. Less demand for energy creates less demand for harvesting fossil fuels. Decarbonization. There is a direct connection between energy production, energy consumption, and the environment. Switch from fossil fuels to low carbon energy, renewable technologies, and nuclear energy. All these options produce very low CO2 emissions per unit of energy compared to fossil fuels. System on chip SoC. A SoC is an integrated circuit that takes the entire computer or electronic system on a single chip. using in small-sized personal computers to reduce power consumption and to improve performance. Even though phones and other electronics and appliances are becoming very energy efficient, that efficiency does not offset the proliferation of these devices around the world and the amount of time they are being used daily. What could be a potential solution? Lead consumers to pick an efficient device, manufacturers to choose the hardware components to create one, and software makers to leverage that hardware. By simply performing a life cycle cost analysis on these products, which includes the power they use once they are in the hands of a consumer, will help identify the features that often worsen the terms of energy use. According to the International Energy Agency, this will cause an immediate drop of energy use and cut the future increase in half. Recognizing the importance of software in ensuring that the components operate at their maximal energy efficient and consuming less power to reduce the amount of toxic fuels released by power plants, therefore conserving the Earth's natural resources and protecting ecosystems from destruction. Thank you.